Alrighty, so here's number 13 from tonight's homework. I chose this example for a couple reasons, and I hope you see why this is an easy problem to make mistakes on, and you can identify where the mistakes are that people might make. So, as with solving equations, when I solve inequalities, my goal is to get the variable by itself. So to get the variable by itself, I need to get rid of this 5. Sometimes people think that they need to add 5 because 5 is being subtracted by v, but this is positive 5. In order to get rid of positive 5, I need to subtract 5. 5 minus 5 is 0. That's what I want. I want nothing extra on that side. And so I subtract 5 from this side of the inequality as well. My new inequality is negative 13. Let me stay consistent here. Negative 13 is greater than negative v. Okay, so I got rid of the 5. I'm still left with the minus sign in front of the v. That's attached to the v. So really, in front of v, we have a negative 1. So to continue solving for v, I need to divide both sides by negative 1. Any time you divide an inequality by a negative or multiply an inequality by a negative, you have to change the direction of the inequality symbol. So negative 13 divided by negative 1 is positive 13, which is less than, I have to change the direction of my symbol, less than v. Some of you may find it more intuitive to write it as v is greater than 13. People really like to have the variable on the left-hand side for some reason, maybe because that's how we read. If you're going to do that, you need to flip the entire inequality over, almost like you're flipping it over a mirror. So you need to make sure that if you flip sides, you also flip the inequality symbol. So we want to go ahead and graph this. When you graph an inequality, I would like to see the important number, so in this case 13, and I also want to see 0. Because 0 is our test point. So by plugging 0 in for v, I can see if I get a true or false statement. In this case, I got a false statement. 13 is not less than 0. And even if I plugged in 0 here for v, I still get a false statement. 0 is not greater than 13. So I'm going to do an open circle over 13 because I don't have the greater than or equal to symbol. And I'm going to point away from 0 because 0 is not in my solution set. I got a false statement when I plugged in 0. Also, if you think about it, I want the v values that are bigger than 13, that are greater than 13. Those are these values over here. Here's number 15. Number 15 should remind you of what we did in class on Friday. So the first thing that I need to do in order to solve this equation is I need to simplify both sides of the equation. So I need to distribute the 2 to everything inside of the parentheses on the right-hand side. And I get 4p minus 3 is greater than 4p plus 2. Now some of you might already be able to see what the solution is. I'm going to come back to that in just a moment. In order to solve, I need the variable on one side of the inequality. So I'm going to go ahead and get rid of 4p on this side by subtracting 4p from both sides. 4p minus 4p cancels, 4p minus 4p cancels, and I'm left with the statement negative 3 is greater than 2. This statement is never true. It's not possible for negative 3 to be greater than 2, so I call this the empty set, that there are no solutions. Now, if I look back to my original inequality that I got once I distributed, I'll try to erase that. Okay, good enough. If I look back to my original inequality that I got once I distributed, I got 4p minus 3 is greater than 4p plus 2. 4p is the same amount. It's the same number because p is the same number. How can I take 4p and subtract 3 and have it be bigger than taking 4p and adding 2? It just doesn't make sense. So I know my answer has to be no solutions. Okay, Number 16 should also make you think of the type of problems we did on Friday. So the first thing I need to do is simplify. So I'm going to go ahead and distribute the 3. And I get 9q, I have to do the curl or else it looks like a 9, minus 12 is greater than or equal to 9q minus 12. So I basically have the same quantity on both sides. 9q and 9q are the same quantity, and I'm subtracting 12 on each side. Look at your symbol, greater than or equal to. 9q minus 12 is equal to 9q minus 12. So this is an always true statement. If I go one step further and subtract 9q from both sides, I get the statement negative 12 is greater than or equal to negative 12. This is a true statement because negative 12 is equal to negative 12. That satisfies this underline portion of the inequality. So my answer ends up being all real numbers. Every number is a solution to this inequality because by plugging any number into this inequality, you will get a true statement.